Question number 1, part A, asks us to subtract two mixed numbers. We have 4 and 2/5, take away 1 1/2. So the whole number part, 4 take away 1, is fairly easy. But those of you who have a good understanding of fractions will realise that 2/5 take away 1/2 will be a bit more complicated, because 2/5 is in fact less than a half. We'll proceed that way to begin with and deal with that when we encounter it. So we have 4 and 2/5 take away 1 first of all, which leaves us with 3 and 2/5. So we'll still to subtract the half part. Now if we look at the fractions, we have 2/5 subtract a half. We can't add or subtract fractions without ensuring that the denominators are the same first of all. So we'll make the denominator 10 on both. That involves multiplying this one by 2 on the bottom. So if we multiply the bottom by 2, we multiply the top by 2. And on the other fraction, multiplying by 5 in the bottom gives us our 10, which means we need to multiply the top by 5 also. So what we have is we have our 3 and 2/5 will now become 4/10. And we are subtracting 1/2, which then becomes 5/10. We can't subtract 5/10 from 4/10, so to get round that, we'll make the 3 2 plus 1 and 4/10, take away 5/10. So now we have our 2 plus, and then our mixed number, 1 and 4/10, which if it was a top heavy fraction is 14/10, which now allows us to subtract the 5/10 part. Just move this up a bit. So we have 2 plus, and then 14/10 take away 5/10 is 9/10. So we get 2 plus 9/10, which is 2 and 9/10, which is the answer. Question 1b again involves fractions. This time we have two mixed numbers and a fraction, and we have two operations. We have an addition and a multiplication. So we need to remember the rules of BODMAS. So we'll write that down to remind us when we're doing this question. That means that we must do our multiplication before we do our addition. That means we're going to have a look at this part here. First of all, our next line of working will be as follows. So we'll write down our 2 and a third. We'll deal with that addition later. So we have 1 and 1/6, and we're multiplying by 3/7. So we're going to change the mixed number into a top heavy fraction. That gives us 7/6, and we are going to multiply by 3/7. So unlike addition and subtraction, we don't need the denominators to have the same value. It's simply top times top and bottom times bottom. If, however, we can simplify across the diagonals, then we should do that. So we've got 7 and 7, which will simplify, and also we've got 3 and 6, which simplifies also. So 7 goes into both 7 and 7 once, and then on the other one we have 3 goes into 3 once and 3 goes into 6 twice. So that allows us to write down the next line of working, which will be 2 and a third plus, and then on the top we have 1 times 1, which is 1, and then on the bottom 2 times 1, which is 2. So we now have our addition left to do. We have 2 and a third plus 1/2. So we'll put down our 2 in order to add the two fraction parts together. This time we do need the denominators to be the same. So we'll multiply this one by 2. Remember to do the same thing on the top, and multiply this one by 3 in the bottom, again doing the same thing on the top. So that then gives us a 6 on the denominator. It gives us 2/6 plus and then 3/6 on the second one. And we now have 2 and 2/6 plus 3/6, which finishes up as 2 and 5/6. There's no further simplification possible, so that's the final answer. Question number 2, we're asked to expand and collect the like terms. So we have double brackets here. That basically means we want to multiply everything in bracket 1 by everything in bracket 2. So we'll do that one thing at a time. We'll take the p from bracket 1 and we'll multiply that by bracket 2, p plus 6. Then the negative 1 from bracket 1, and again multiply that by the second bracket, p plus 6. So first of all, p times p is p squared, and then we have p times 6, which is 6p. Then it's negative 1 times p, which is negative p, and then negative 1 times positive 6, which is negative 6. We're looking for any like terms, so we have our positive 6p here, and right beside it we have negative p. So when we put those together, that gives us p squared, and then 6p minus p is positive 5p minus 6. No more like terms, that's it, fully simplified, so that's the answer. Part B, again, we want to expand and collect the like terms. This time it's a single bracket with a squared on, so what that means is we want to multiply the bracket by itself. So that'll be our second line of working. So it's 3w minus 2 multiplied by itself. So once again, we want to multiply everything from the first bracket by everything in the second bracket. Doing that one thing at a time, we'll take the 3w from the first bracket and multiply the second bracket, 3w take away 2. And then the negative 2 from the first bracket, again multiplying the second bracket, 3w take away 2. So 3w times 3w, 3 times 3 is 9, w times w is w squared, and it's negative. 3w times 2 is 6w, and then negative 2 times 3w again is negative 6w, and then we have a negative 2 times another negative 2, so the answer is going to be positive, and 2 2's make 4. Once again, we're looking for like terms. We have negative 6w here, and right beside it another negative 6w. So putting those together, on the next line we will get 9w squared, negative 6 take away 6 is negative 12w, and then our plus 4. No more like terms and no more simplification possible, so that's our final answer. Part C, we have another set of slightly more complicated double brackets to multiply out. So once again, we need to multiply everything from bracket 1 by everything in bracket 2. So we'll take the 5x from the first bracket and multiply that by the second bracket, 3x take away y. And then we have plus 3y from the first bracket, again multiplying the second bracket, 3x take away y. So what we have to begin with is 5x times 3x. So the 5 times the 3 is 15, and the x times the x is x squared, and it's take away. So next we have 5x times by y, which is simply 5xy. Then we have positive 3y times by 3x. So we have plus, and then 3 times 3 is 9, and then y times x is yx, which is just the same as xy. We'll write it like this so it looks like the previous term and more easily identified as a like term. Then finally we have 3y multiplied by negative y, so that will be a negative, and the y times the y gives us y squared. So our like terms that we pointed out will be negative 5xy and positive 9xy. So the next line of working is 15x squared. We then have negative 5 add 9, which is plus 4xy, and then negative 3y squared on at the end. There are no more like terms, so no more simplification is possible, which means this is our final answer. Question number 3 on the non-calculator. The population of a Scottish village has dropped by 45%. If the population is now 440, what was the population originally? So the original population is represented by 100%. Our population has dropped by 45%, which means our current population is represented by 55%. So this question is a reversing a percentage change question. So if we know that 55% is 440, we need to find a way back to 100% without using our calculator. So the percentage we want to find as our step in between 55 and 100 is 5%. That's because we can easily go from 55% down to 5% simply by dividing by 11. If we divide by 11 on that side, then we must do it on the other side also. 440 divided by 11 is 40. So we have chosen 5% as our in-between step because getting from 5% back to 100% is also a fairly easy process. So 100% is the original population percentage. To go from 5% to 100% means that we need to multiply by 20. So if we multiply by 20 on one side, we must do it on the other. Again, this is easy to do without a calculator. We have two zeros, so if we ignore those for the minute and we just do 2 times 4, that gives us 8. And then add on the 2 zeros, that gives us 800, which represents the original population of the village. This is question number 4 and the first in the calculator section. We're told the population of the country Liberia was 3.75 million in the year 2007. If the population is growing at a steady rate of 4.5% per annum, which means per year, what would the population be in 2015? And then importantly, it asks us to give our answer correct to 3 significant figures. So we're talking about a population increase of 4.5%. So if we add that to 100%, because it's an increase, that gives us 104.5. If we want to write that percentage as a decimal, then that will simply be 1.045, which will be our multiplier. So to set this one out, we want to first of all write 3.75 million in figures, which is 375,000,000, multiply by 1.045, and then it's over a period from 2007 to 2015, which is 8 years, so that becomes our power. So if we then simply put that into a calculator, we get 5,332,877 point, and then our digits continue after the decimal point. Now, we had noticed earlier that we wanted to give our answer to 3 significant figures. So these are the 3 most important figures in our number, which is the first one, the second one, and the third one. Now this is the point we will round our number. So the digit after the number 3 is a 2, which means that number 3 will in fact stay as number 3. So our answer will be 533. Now, obviously, the population of Liberia isn't 533, so we need zeros as placeholders where the other digits were, which gives us our final answer corrected to three significant figures of 5,330,000 people. Question number 5 in the calculator part. The cross-section of the shape shown consists of a rectangle and a triangle. Calculate its volume. Then it asks us to make sure we give our answer correct to the nearest 100. So this shape that we're looking at, this three-dimensional shape, is known as a prism. We should know that the volume of a prism is given by the area of the cross-section. That's the area of the end face here, multiplied by the length, which is the measurement going from the front to the back. So that now we can easily see that that measurement is 10, but what we don't yet know is we don't know the area of the cross section. Now the cross section or the end face, as it tells us in the question at the top, is made up of a rectangle and a triangle. So we can clearly show that if we draw a line across here. So our triangle part, which I will shade here in red, is at the top, and the rectangle part, I'll shade that down here in yellow at the bottom. So we'll do those separately. We want to work out the area of the red triangle, and separately what we will want to do is work out the area of the yellow rectangle. So looking at the triangle first of all, the area of a triangle formula, A equals a half times the base times the height. So the base and the height are the measurements going along here. That's our base and our height. Now quite clearly the base of the triangle is the same as the base of the rectangle, so the base will be 16. The height, however, isn't obvious, so if we look at the height from top to bottom for the whole shape, that's 22, whereas the height from the bottom up to this point here is 14.5. Now if we subtract those two, then that will give us the measurement of the height of the triangle. So it's obviously not drawn to scale, this diagram, because it doesn't look quite right. But anyway, if we take 14.5 away from 22, then we get our height, which will be 7.5. So the area of the triangle will be a half multiplied by 16 times 7.5. So we're allowed to use our calculator at this point. That gives us an answer of 60 square centimetres. So that's the triangle part. What we want to move on to next is the rectangle. I'll move this up to give us slightly more room. So the head we'll write down is area of yellow rectangle. That makes it nice and clear what we're doing. So we should know that the area of a rectangle is given by the length times the breadth. So the length and the breadth, as we can see for a rectangle, 16 and 14.5. So our area is equal to 16 times 14.5. Again, if we use our calculator for that, and that gives us our answer for the rectangle area at 232 square centimetres. So we now have the area of the two separate parts. We have the area of the red triangle at 60, square centimetres, and the area of the yellow rectangle at 232. That means that the total area of the cross section will be these two numbers added together. So we'll put that down at the bottom, total area. So this time we won't need our calculator. 232 add 60 is what we're looking for, which then gives us our answer of 292 square centimetres. So that's the area of the cross section. So that's what was required for our prism formula. So we can now take our cross section area, 292, substitute it in here to our area in the prism volume of a prism formula. So we'll do that now. So the volume of our prism is going to be V equals 292 multiplied by the length, which we will remember is 10 centimetres. So 292 times 10. Once again, no real need for a calculator here, just add the 0 on. So 2920, and since it's volume, it's now cubic centimetres. So the volume of our shape, the prism, is 2920 cubic centimetres.